The cross-section is a major segment of a circle. M is the midpoint of AB, and CM is perpendicular to AB. That means they meet at 90 degrees. This is 90. This is also 90 degrees. CM is 8 centimeter. Find the cross-section area, which means we need to find the area of this part, these two parts, the unshaded part. We call it the blank part. So how do you find the area of this major segment? Now, for you to solve this question, the most important part is to identify the center of this circle. How do we know the center of the circle? The center of the circle will be along CM because it is clearly explained to us or identified in the question that CM is perpendicular to the chord AB. If we try to complete this is a circle, okay, and AB is a chord. One of the properties of chord is that any line that passes through the center of a circle will be a perpendicular bisector of a chord of a circle. That's why this line CM passes through the center. Therefore, any part on CM, let's say probably here, is the center and we call it O. So far, we don't know the measurement of the center of the circle. Now, what we need to do is we need to join O to A and O to B. Those are the radius of this circle. Okay. Now, if we have CM, if we assume OM to be H, then CO will be 8 minus H, since the whole of CM is 8 centimeter. CO is also the radius of the circle. Okay. Now, having said that, this information will help us get the radius of the circle by using triangle AMA. Let's even try to remove that triangle. MOA. OA is the radius. OM is 4 centimeter. AM is 4 centimeter, and OM is H. So we can use Pythagoras theorem. We can say the radius squared, which is the hypotenuse squared, is the same as the base squared, which is 4 squared plus the height squared. But we said that R is also 8 minus H. Therefore, we can substitute R as 8 minus H squared equals to 4 squared is 16 plus H squared. If we try to expand this, we are going to get 64 minus 16H plus H squared equals to 16 plus H squared. At this point, H squared will cancel with H squared. Therefore, collecting the like terms, we are going to get 64 minus 16 is the same as 16H. And therefore, 48 is equivalent to 16H. Dividing both sides by 16, H is the same as 3 centimeter. Okay? But H is not the radius of the circle. The radius of the circle, R, is the same as 8 minus H, which is R 8 minus 3. R is therefore 5 centimeter. Now, the next step is to identify the angle subtended at the center of this circle. So we're going to find the angle here, subtended between here. Now, we can use triangle AOAM still to find the angle subtended here. Once we get that, it will be the same as this one also. But to get this, we are going to use angle on a straight line, which means that angles on a straight line add up to 180. And therefore, once we get this is 180 minus this, which is also the same as this one. So let's call this angle theta. Okay. Now, this is right angled at M. AM is 4, OM is 3, and AO is 5. We can use one of the trigonometric identity, tan. You can say tan theta. Tan theta is the opposite side to the theta, which is 4, and adjacent side, which is 3. To get the angle, we say angle theta will be tan inverse of 4 divided by 3. Using a calculator, theta in this case will be 53.13 degrees. Okay, so this angle is 53.13. This one is also 53.13 because these two triangles are the same. To get this angle, we take 180 and subtract 53.13 because those two angles lie on the straight line CM, and that gives us 126.87. So here it's going to be 126.87, and this is also 126.87 since the two triangles are the same and both of them lie on the straight line CM. Okay. Now the area of major segment will be the area of two sectors plus the area of the triangles. Now, which are the two sectors? The two sectors are this one and this one. Okay. How do you find the area of a sector? The area of a sector is given by theta over 360 times pi r squared plus area of a triangle is a half base times height. And the triangle in this case will be ABO. So the upper part of this circle, which is the major segment, is the area of these two sectors, this sector and this sector, plus the area of triangle AOB. Okay. Now, what is our theta in this case? Now, what you're going to do is, since the angles subtended by these two sectors are the same and they have the same radius too also, we need to get only the area of this one sector and multiply by 2. Okay. So this is going to be 126.87 divided by 360 multiplied by 22 over 7 times the radius squared, which is 5 squared. Okay. And this is going to give us, okay, multiplied by 2 because there are two of them, and then plus a half. The base is AB, which is 8, times the height 3. Okay. This is very simple. By 2, 1 by 2, 4. The area of the triangle will be 12 centimeters squared. That's very simple. Okay. Now, how about this? We need to use a calculator to get the area of one of the sector and then multiply by 2. And the area of one of the sector will be 27.69 using a calculator. And then we multiply by 2 and then add 12. Now, using board mass, we have to multiply 2 before we add. So 27.69 will be the same as 55.38 centimeters squared plus 12 centimeters squared will give us the area of the major segment or the cross section as 67.38 centimeters squared, rounded off to 2 decimal place.